Welcome to the MAT081 review for the first test that we're going to be taking, the first of four. This will cover units 1, 2, and 3. So one of the first things you want to do is go into MathAS. Here it is. And you want to get into the Unit 3 review. I'll show you from the course itself. Student view. So as you enter the course, here's Unit 3, or Units 1 through 3 review. First thing you should have done already, or be well on the way, is you should pull up the paper review for Units 1 through 3. This first review is just a bunch of questions, so you're welcome to work through this, and I encourage it. But I also highly encourage you complete these 46 problems which as a paper review. They're open-ended, fill-in-the-blank type questions. As you work through this, you will have come across all the concepts that you will need to understand for our upcoming tests. And to assist you, there's solutions to the Unit 1 review. So you can pull up this link here, and it's the same paper version, but it's been completed with highlighting and so forth. Okay, so it gives you a way to sort of think your way, work your way through it. But there's no audio with it, so the other thing is there's video solutions to each of the problems. So you click here, this will take you to YouTube videos that have been completed. So questions 1 through 4 are here. You click on it. Let's say you had a question about number 3. I'm going to pause that right now, but you could fast forward until you got to about question 3. Okay, and then you could play there. Or question 4, you can fast forward, you can go forward, backwards, or you could watch all 4. So go through these videos for the ones that you weren't quite sure how to do or you needed some help with. Okay, so that's all the reviews: paper review, solutions, and the videos. And then now you're ready for the practice test that I handed out this last Wednesday. So the paper review was given a week ago. The practice test was just given out, and you can pull that up and start working through it. It will be the same experience. It's 15 questions, multiple choice, very similar to the format of the test that you're going to be facing next Wednesday. Okay, so I'm going to go through this. I'll give you a few details of what you should, sort of the concepts you should focus on, and then I will actually work through each of the 15 questions. I highly recommend that you do the questions on your own first and come back and review the ones that maybe you had questions on or weren't sure of. Okay, so I'm going to get this out of the way, and let's go ahead and start here with a little bit of review. So first of all, since this is replacing the live stream of a core of the class, we're going to do our word of the day. So this is going to verify your attendance in class, either through the video, or if you were there, you would have seen that the word of the day was reservation. And we used it in the sense that reservation, it doesn't look like it's spelled correctly, but reservation. I better double check that. You double check it, you let me know. Reservation, it just doesn't look right. We used it in the sense that after you've reviewed all the materials, you would have no reservations about the test. You would be completely ready. Okay, so part of the things we're going to talk about to get you ready for this test is there are really two meanings for the sign. This. In one sense, when it is between two numbers, say this, we read this as 5 minus 3. So in this sense, it is the operation of subtraction, and it's read as minus. And sometimes we call it the minus sign, but we want to be careful about that. We want to refer to it when it's in front of a number, say as if it were to appear just like as this, a sign in front of a number, and oftentimes we'll have parentheses around it. That when it's like this, we want to refer to it as a negative sign, not a minus sign. So those are the uses of the words, because one of the questions you're going to face will ask you to say, read this sentence, this mathematical sentence. And you see the use of a lot of this sign. The first one is a negative, so we say negative 7. The middle one is a minus, and the last one is a negative. Okay, so just a little practice, a little details on how to read each one correctly. Another thing you're going to need to know is how to order numbers from smallest to largest. So my question is, which number is bigger? This one or this one? Now some would say the 12 is bigger, but it's got a negative on it, so negative 12 or 10. And the way to determine is really to lay them out on the number line. So we'll put 0 about here. Negative 12 is to the left, and 10, positive 10 would be somewhere about here. So negative 12 is a smaller number, 10 is the larger. And we define it because to the left, any number to the left is a smaller number. The left is smaller. But the right is larger. Okay, so be able to do that to put some numbers in order and maybe use the number line. We'll look at an example of that. Also, you need to understand about place value. So I'm going to pull over here from one of the mini lessons. Actually, it's hard to read that, isn't it? So what I'm going to do is I'm going to take a picture of this. Actually, I don't need to take a picture. I'm just going to move to the next page. Come over here. Know this chart very well, inside and out. So every 3 digits we put a comma. The lower digits are the ones, so ones, and then we call the next ones tens and hundreds. Then we have the thousands section, 1,000s, 10,000s, 100,000s. Then we have the millions and the billions. And of course in the millions we have 1 billions, 10 billion, millions, and 100 millions. And the reason is we're going to ask you questions. We'll give you a number such as this, and we'll ask you, for example, which digit is in the 10,000s place? Well, the 10,000s place is right here. Right here. So it's 1, 2, 3, 4, 5 over. 1, 2, 3, 4, 5 over, so it would be the 3. So be able to identify digits in the various places. We're also going to use it to round. So if the question had asked you to round to the 10,000s place, we look at the 3, and then we look just to the right. If the number next to it is 5 or bigger, which means we're half the way closer to the next number, we're going to round it up. And what do we round this up to? 2, 6, 1, 9, 4, 2, 0, and then the 3 is going to get rounded up to a 4. And then everything behind it becomes a 0 now. So that's rounding. We're closer to the number 2, let's see what this is, 261,942,040,000, and we're done. Okay, so that's what rounding up. If the 7 was, say, a 4, if it was less than 5, we would round it down. And when you round down, it doesn't seem like you're doing anything because you don't actually change the number. You don't go down from 3 to 2. But watch, this would have went to 2, 6, 1, 9, 4, 2, 0, 3, 0. So it would have gotten rounded down because it's actually going to the next smaller number. Okay, but in this case, the correct way to do it is to round it up. But these are the two possible answers. You either round up or you round down. This is the round down answer. But again, in this place, since we have the 7, we choose to round up, or we have to round up. Okay, so that's that concept, rounding and place value. Let's see, the other thing we're going to talk about, let's get a new page here, is words that we might use for the different operations. So the operations we're going to be dealing with when we have, say, addition. Certain words we'll see are things like increase, possibly more, but more is sometimes because we're more than what? Which one? We're either adding something or sometimes we're subtracting it depending upon which one we're going to discuss, which one we're referring to. Okay, so you'll have some word problems and you've got to decide, do you add, subtract, multiply, or divide? So these words will give you a little bit of a hint of which way to go. For subtraction, you're looking words like maybe less, difference. Whenever we want the difference between two numbers, we always subtract. But remember, subtraction needs to be ordered in a particular way. And also when things change, when we're looking for change, that's a subtraction operation. When do we multiply? Which is either this X symbol or the dot. The word by oftentimes is used. The word times, and some by so many times, that signifies multiplication. And whenever we're talking about something being multiple times. And finally division, which is either this symbol or sometimes is listed like that. When you're dividing things among people, you're splitting things up. You're sharing it with each person, or to share. So those were some words we came up with, not necessarily an exhaustive list, but something that we'd want to consider. And then, what else did we look at? We looked at something called an LCM. And it's important to translate that into what it means. It's the least common multiple. So we're going to put emphasis here on the word multiple. Least means it's the smallest. Common means it's shared, and multiple means it's a number that it would divide into. It is a multiple. So let's give some examples here, and the way I'm going to suggest to do it is a little bit different than what is suggested in the videos. but I think this will lead to greater understanding. So if we're talking common, we always need two numbers. So let's just choose two. Here, how about 6 and 15? That was the example. We're looking for the smallest common multiples. So what I'm going to do is I'm going to take each of these numbers and I'm going to get their multiples. So I'm going to multiply by 1, by 2, by 3, by 4, and so forth until I find that common multiple. So 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. These are the multiples of 6. 4 times 6 is 24. Okay. 1 times 15 is 15. 2 times 15 is 30. Ooh, we're getting big. 3 times 15 is 45. We haven't found any common multiples yet. So I better pick up over here. How about let's go to 5 here. 5 times 6, well that's 30. And then let's go to 6. Oh, wait a minute. Hold the boat. We've got a 30 here and a 30 here. That's what's called a common multiple. And it was the first one. It's the smallest. It's the least one. When you do it this way, it just means you're going to stop when you get to that first one. We could keep on going and we'll eventually get another common multiple, but it'll be larger than 30. And why do all that work when we're really already done? So again, the videos was in the book, in the MAT081, they'll show you maybe factoring and then looking for common factors and that kind of method. That does work. It's valuable. But I think greater understanding comes when you just list the multiples and find the common one. It'll be probably easier as well. Okay, so the LCM for this one, for these two numbers, is 30. LCM is 30. And that's how I would suggest doing these common multiples. Okay. The last concepts we really need to look at is along with this factoring is prime numbers. So what is a prime number? It's a number that has only one and itself as factors. Factors are two numbers that multiply to give you a number. Factors are two numbers that multiply to give you the number. So an example it's oftentimes easier to look at things that are not prime numbers and when we're going to talk about prime numbers. So a number like 6, is that prime? Well, no, because we know that 2 times 3 gives us 6. It has two factors that are not one in itself, in addition to one of itself, that give us 6. Now yes, 6 is also can be factored as 1 times 6. But it's also got 2 and 3, so this is not prime. If you study number theory, it's called a composite number, but the main thing we're going to focus on are prime numbers, okay, not prime. So the things that are prime, one's usually not included. I don't know, maybe they do, but one's kind of like, who cares? So the ones we want to focus on is that 2 is a prime number, because only 1 times 2 is 2. 3 is a prime number, because 1 times 3 is prime. 5 is a prime number. Then we jump to 7. And then 8 is not prime because 2 goes into it. 9 is not prime. 10 is not prime. 11 is prime. 13 is prime. 14, 15, 16 are not primes, but 17 is. And, so it's just, we'll look at a few of these things. 19 is a prime number. 20, 21, 22 are not primes, but 23 is. So we notice a little bit more space happening. 24, 25, 26 are not primes. 27 is not prime. 28's not prime. I believe 29 is. Check me on that last one. But that's about as far as we need to go. I'm going to show you the things we're going to do with this is prime factoring. So these are the ones that we're looking for. These are primes. Okay. Very good. So I'm going to go to one more page so that we can talk a little bit about factoring. So we're going to talk about divisibility checks because you might be given a number. Let's choose 56. And you might be asked to get the prime factors. Or you're asked, is it prime? Well, there's some divisibility tests. We're going to check some things. So if 2 goes in this number, it's not prime. So how do we check about 2? Divisibility check for 2 divisible by 2 is that if the number is even, then it can be divided by 2. So all even numbers, well, except 2. 2 is the only even number that's a prime. After that, every even number is not prime. Okay, so that's a first check you want to do. 56 is even, so it's not prime. And what does it mean to be even? It means to end in the numbers 2. I guess we could start with 0, 2, 4, 6, or 8. If you end in any of these digits, then the number is even. There's a divisibility test for 3. And what that is you add the digits. And if the result is divisible by 3, the original number is divisible by 3. So an example, how about the number 131? 1 plus 3 plus 1, 3, 4, 5, that equals 5. 5 is not divisible by 3, so 131 is not divisible by 3. You could also do a check by running it through your calculator. Over here. So we can try 131 divided by 3, and you get decimal, so you know it doesn't work. However, let's take the next number, 132. 1 plus 3 plus 2, so that it gives us 6. We know that 6 is divisible by 3, so 132 will be divisible by 3. And we get an integer value of 44. Okay. So that's that test. One more test to consider, and that's the divisibility by 5. And that rule is basically it has to end in a 5 or a 0. Okay. Then it will be divisible by 5. So those are some quick checks to see if something is not prime. It's not prime if any of these divisibility tests prove accurate, if it's divisible by 2, 3, or 5. So that's a quick one to do. If it's not, the other way to check for a prime is then we might try the next on the list of primes. Right? Let's go back a step here. The other primes are 7, 11. or 13. And those are the only ones we really need to check. If we check 2, 3, and 5, if those don't work, 4 won't work, 6 won't work, and so forth. So we just check the primes. You only have to check for prime factors. Then you could check 7, check 11, check 13. And what I mean is you take the number divided by those. Okay, divided by those numbers to check for whether it's prime or not. Okay. So 56, we know it can be divided by 2, so one way of prime factoring is we divide by 2. 2 goes into 56. So it goes into 50 25 times, and then it goes into 6, 3, so 25 plus 3 is 28. Again, plug it into your calculator as well. 2 we know is prime, so that's going to be the end of that route, but 28 can be divided by 2. It can also be divided by 4, so you can go with that route if you'd like, but 2 goes into 28. That's going to happen 14 times. And then 2 goes into 14 7 times, and we know 7's a prime, so what we have here is our prime factors. 2 times 2 times 2 times 7. 2 times 2 times 2 times 7. Okay, so that would be the prime factoring. Now, an incorrect prime factorization would to say, well, we got 2 times 2 times 14. This is not correct. Because 14 is not prime. Okay, so we don't want to... So there'll be questions and they'll give you prime factorings. They'll give you factors that do multiply to give you the number, but you're looking for the one that has all primes. Okay, and I think that takes us about to the end of what we covered during the class. So now I'm going to take a little break, and this will be the class video. What we did in class is then I passed out the practice tests and gave everyone the opportunity to work through it. I'm going to do the same thing for you right now. I'm going to give you a little bit of time, work through the test, do the best you can, try to figure out whether you got it right or wrong. And over the weekend sometime, at a random time, I will post a video that has solutions to each of the problems in the practice test. Again, where do you find that practice test? Well, it's in MAT081 right now. Page forward, oops, page back, get a new page, practice test here, right here. Pull that up, work it out, and check back in a couple days, Saturday or Sunday, and I will have it posted, video solutions to the practice test. Study hard, study often, practice a little bit each day, and you'll be well prepared for our test on Wednesday. That will allow you to keep moving ahead. Please contact me with any questions. I'll make a personal video for you working through a few problems. Just let me know which ones they are exactly, and I'd be happy to do a little video that works you through those problems. Thank you very much for watching. Remember that word of the day, reservation. The quiz will be posted along with this video in Canvas. Thank you very much. Take care. We'll see you soon.